Calculus is a journey of discovery. 1 year to master the language of change. Are you ready? Let's begin.
Hello everybody, welcome to IgweCalculus week 11. This week we are given an integral to evaluate. The integral is 1 over 9 minus 4x squared dx. So we should evaluate this integral. Now, before we evaluate this integral, I want to point out that the easiest way to solve this is using trigonometric substitution. Most of the time, in the beginning part of calculus, you've been hearing about use substitution, that is to change a part of the solution to u. That is, you can say let u equal to 4x squared. Yeah, this is a way to solve calculus question, but the easiest way to solve this type of calculus question is using trigonometric substitution. Now, what do I mean by trigonometric substitution? You can hear trig, so you are familiar with triangles. So we are supposed to draw some triangles, and specifically the trigonometry deals around right angle triangle most of the time. So we're going to draw several right angle triangles now. Okay, let's draw a right angle triangle like this with a hypotenuse of x and an opposite of a. And here is our theta. Then you can agree with me that sine theta is equal to opposite over adjacent over hypotenuse, opposite over hypotenuse. So sine theta is equal to a over x. Good. Now, how do we find the value of the adjacent side? That adjacent side is equal to, let's call the adjacent side L. L squared plus a squared is equal to x squared. And this is from Pythagoras theorem. The sum of the opposite and adjacent is equal to, the sum of the opposite and adjacent squared is equal to the hypotenuse squared. So L squared plus a squared is equal to x squared. This implies that L squared is equal to x squared minus a squared. And finally, L is equal to the square root of x squared minus a squared. So here we have the square root of x squared minus a squared. So if sin theta is equal to opposite a over hypotenuse x, then you agree with me that x is going to equal to a over sine theta, and that means x is going to equal to a cosec theta. What this means is that when you have the square root of x squared minus a squared, what you are going to use is x is equal to a cosec theta. Now this is just one triangle. Let's find other triangles. Now if you draw another triangle, let's say instead of x being at the top here, let x be on the opposite side. Then here is a and here is theta. Then you agree with me that sine theta is equal to opposite over hypotenuse. So opposite is x and hypotenuse is a. So we have that x is equal to a sine theta. Now when do we use x equals a sine theta, not x equals a cosec theta? You use this when you can get what we are going to use this when we find this last side. Now what's the end of this last side? We have x squared plus l squared is equal to a squared. We have l squared is equal to a squared minus x squared. We have l is equal to the square root of a squared minus x squared. What this means is that when we have the square root of a squared minus x squared, the one we are going to use is x is equal to a sine theta. Let's find one more. Remember, the first triangle we did, here was x, here was a, and here was the square root of x squared minus a squared. The second triangle we did, here was a, here was x, and here was the square root of a squared minus x squared. Now, you've seen x squared minus a squared, you see a squared minus x squared. Now, what of a squared plus x squared, or x squared plus a squared? Well, that would be the same thing. A squared plus x squared is the same as x squared plus a squared. So you should know that the last triangle we are going to find, we need to find when here is going to be square root of x squared plus x squared. Now, the easiest way to do that is, instead of having that square root of x squared plus a squared on the opposite or adjacent side, we will turn that square root of x squared plus a squared to be the hypotenuse side. So our third triangle, our very last triangle, we have an opposite of x and an adjacent of a. So we have an opposite of x and adjacent of a. Remember, here is still our theta, here is still theta, and here is still theta. Then the hypotenuse side is now going to be x squared plus a squared. You can find this using Pythagoras theorem. X squared plus a squared is going to be the hypotenuse squared. Square root both sides, then you have the hypotenuse equal to square root of x squared plus a squared. So the hypotenuse is equal to square root of x squared plus a squared. Now let's do the same thing for this triangle. Now we need to find something that relates a and x. Well, tangent relates them. So we have tan theta is going to equal to opposite over adjacent. So that's x over a. Now if you cross multiply both sides, you have x is equal to a tan theta. What this means is that when you have the square root of x squared plus a squared, the simplest one I'm going to use is x is equal to a tan theta. Now as always, you should know that all these things they come in pairs. Tangent is related to something, tangent is related to cotangent. Sine is related to something, sine is related to cosine. And cosec is related to something, cosec is related to secant. So as always, even when you now move this theta from here to this side, then what you get here is x is equal to a sec theta. By the time you move this theta to this side, what you get here is x is equal to a cos theta. By the time you move theta from here to this side, what you're going to get is x is equal to a cotangent theta. But the reason why I didn't do that is because by the time you find the derivative, you will have a negative sign. The derivative of x is equal to a sin theta, you have the x is equal to a cos theta. But let us say you have x equals to a cos theta here. Then by the time you find the derivative, you are going to have the x is equal to negative a sin theta. You can see that. So the moment you are using the opposite of them, you are going to have a negative sign. And then you differentiate cosec theta, it will be the negative of when you are differentiating sec theta. I'm not sure if it's the negative, but like you have a negative sign. That's what I'm sure. It may be other three functions that you get, but then you have a negative sign. By the time you find the derivative of sec theta, you also have a negative sign. So the easiest one to do is to just leave it as you having only the positive answer. The derivative of tan theta is equal to sec squared theta, positive. That's why we are always. That's why in maths your teachers always tell you should use this tree whenever you are solving a question in this form. And it's the simplest way to use because we don't want to be having negative signs because negative sign confuses us most of the time. By the time you are solving a question, you are solving and you get x minus a. You can confuse when you are having a negative. So it's better to solve using positive. That's why they pick these three as standard ones. But as always, you can also try your best and you can also try to solve it using x equals to a sec theta, x equals to a cos theta, and x equals to a cotangent theta. It will still give you your correct answer. But as you know, it will be negative. So you have to watch out for those negative derivatives. But now that we have seen how we got this formula sheet from these two triangles, we are going to now apply it to solve this question. The main two that there are three here, but the main two you should remember is x equals to a sin theta and x equals to a tan theta. X equals to a sin theta is what we're going to use here because remember what you're seeing here is in the form of a squared minus 4x squared. So you have a squared minus x squared. It's going to be x equals to a sin theta. Whenever you have plus, the easiest way to use is tan theta. When you have x squared in front of the a squared and it's negative, then you can go with x equals to a cosec theta. Well, now that we've crossed that part, let's now solve this question. I've actually seen a question like this before I knew about cosec and sec theta. That's why I was taught what cosec theta and sec theta is. I actually solved this type of question using x equals to a sin theta. It's possible. It's not that it's not possible. It's possible to solve using x equals to a sin theta. But after solving, and I've got sine. I think it was sine I theta or something. I think that was sine I theta or I sin theta. But that's when already before I knew what cosec theta and tan theta and sec theta is, I already know what hyperbolic sine was and hyperbolic cos and hyperbolic tangent. So I was able to solve this using hyperbolic sine, hyperbolic cos, and hyperbolic tangent. But then I said that will just make it work a lot harder. So it's better for you to know this tree than for you to start using x cos a sin theta to try to solve this and then make it work complex. Anyways, let's solve this question. I've done a lot of introduction to how we get this because and that let me just deviate a little bit more. Somebody once met me and I was like, so that means math is just like it's not math, not like it's not something that you should work hard for. Just learn the method and then you will. So I don't know that there's a reason why your teacher only teaches you to use this. It's because this is the easiest way. It's not like that other ways are impossible. No, other ways are still possible, but this is the easiest way. If they go to class start telling you, oh, do this way, manipulate it, use hyperbolic sign, use imaginary numbers, or to make the work complex, and some of us don't want to learn it. That's why the only way some teachers just teach you these easy ones and just move ahead. So yeah, I will show you the reason why we use these functions. Okay. So now for this particular question, we have the integral of 1 over 9 minus 4x squared dx. Which of these are we going to use? Let's analyze. First of all, we have 9. 9, if I any number, if I even if it's 10, I know 10 is not a perfect number, it's not a perfect square. But even if it's 10, you can have the square root of 10 all squared. You see what I'm doing here? You have square root of 10 all squared, so you still have the a there. Then we have, but let us put as 9. So we have 9, and 9 is the same thing as 3 squared minus what? 4x squared. We can put that 4x squared into a bracket. So we have bracket 2x all squared. So you can see we have 9 minus 4x squared. It has come to 3 squared minus 2x all squared. Now let's compare this to our table of values here, or our formula sheet here. We have a constant squared. We have a constant squared. We have negative. We have negative. We have something with the value of x squared. We have x squared here. So all in all, this is the one we are going to use. The square root of a squared minus s squared, and we translate it using x equals to a sin theta. But instead of x here, remember here we have x, here we have 2x. So instead of x, we're going to use 2x is equal to a. Our value of a is 3. 3 sin theta. Remember, if it was 10 that was here, then here will be square root of 10 all squared. So your value of a will not be 10. Your value of a will be square root of 10. So here we have 2x is equal to 3 sin theta. So I can clean our formula sheet here. We don't need this. So this is the trigonometric substitution I'm going to use. It's going to be the simplest one to use. I said it's not like there's no other way you can use. You can use 2x is equal to 3 cos theta. You can use any other tree apart from tan and cotangent. But I believe you can also use, I've never tried using cosec and sec theta. I said that ones are more complex. But I've never tried using them. But I believe it's possible that you can use them and manipulate some things. But this is the easiest one, no negatives. I don't think there's any negative here. It's simple, straightforward. You hit on the nail, I have got your answer. So now let's find the derivative of both sides. Because remember, we have the trigonometric substitution to get for your 2x here. But you need to also substitute something for your dx. Because remember, here is dx here. So let's find the value of dx. So now if you differentiate both sides, you can do two ways. You can either divide both sides by 2 or differentiate straightforward. I'm not going to differentiate straightforward. But I think I'll still divide by 2, but let me just differentiate straightforward. So we have 2 dx is equal to 3 cos theta d theta. Now I know some people will be confused. How come there's dx here and there's d theta here? Well, it's simple. If you are differentiating the normal way that most of you know, then what you are going to have here is 2 is equal to 3 sin theta d theta dx. So you are differentiating sin theta with respect to x. So you have d theta dx will be attached to that back using chain rule. Then you multiply both sides by dx. So you have 2 dx is equal to 3 sin theta d theta. It's the same. Oh, sorry, 3 cos theta. And then you differentiate, it's going to be 3 cos theta. 3 cos theta. So you have 2 dx equal to 3 cos theta d theta. It's just that whenever I'm solving all this trigonometric substitution, I will just go straight forward and just go, here we have dx and here we have d theta. Instead of going the whole way of saying, okay, dx over d theta, then multiply both sides by d theta, or d theta over dx, then multiply both sides by dx. Instead of doing that one, I just go straight forward. The x will have dx and the theta will have d theta. So it will be easier, I just go straight forward and substitute our value of dx. But if you are not that kind of person that knows this straightforward, then you can just go the normal way, d theta over dx, multiply both sides by dx. And also depends on your teacher, because I believe in secondary school they will still make you want to go to that method of theta over dx, then multiply both sides by dx. But if you are university, I believe you can just go straight forward and just say 2 dx is equal to 3 cos theta d theta. Okay, now we have dx here, we have 2 dx here, but we have dx, so you can divide both sides by 2. So if you divide both sides by 2, you are going to have dx is equal to 3 over 2 cos theta d theta. Now this is good. Now we have the value of dx, which we are substituting up here, and we have the value of x. You can just say x is equal to 3 over 2 sin theta. But I'm going to leave it like this. 2x is equal to 3 sin theta. You know I'm going to leave it like that because I've already shown you why we have 2x instead of just x. Because then we have 4x squared. So I'm just going to use the substitute. But anyways, now I've gotten what we're going to substitute with. So now by the time you substitute, we have the integral, the x turns to 3 over 2 cos theta d theta, all divided by 9 minus 4x squared is no more 4x squared. 4x squared is now 2x all squared. So we have 2x all squared. But this 2x is something else. This 2x is equal to 3 sin theta. So we have 3 sin theta all squared. Now I've done all the substitutions, so we don't really need any of this again, so I'm just going to clean it off. Actually, we need something from here. We needed that 2x is equal to 3 sin theta. But I believe you have that in the back of your head already, because I'm going to remember that later. So let me just clean this off. Because remember, after you have changed everything to theta, there's no more x here, there's no more u here, there's no more here, only theta. You still need to change everything back to x. That's why you need that substitution, but that's why you need that trigonometric substitution that you made. But I'm not going to, since you already know that 2x is equal to 3 sin theta, I'm not going to tell you people that you should recall that we had that substitution in the first place. So now, what do we do with the denominator? We have 9 minus 3 sin theta all squared. Now 3 sin theta all squared, by the time you square all through in the bracket, you have 9 sin squared theta. 9 minus 9 sin squared theta, you can factor out the 9, so you have 9 brackets 1 minus sin squared theta. Remember from trigonometric trigonometric rules, you have sin squared theta plus cos squared theta is equal to 1. That means cos squared theta is equal to 1 minus sin squared theta. So you have 9 times 1 minus sin squared theta will turn to 9 cos squared theta. Sorry. Okay, so instead of 9 minus 3 sin squared theta, we are going to just have 9 cos squared theta. 9 cos squared theta. Good. Now let me just do some manipulation with the numbers that we have here. So we have 3 over 2 divided by 9. Division sign changes to multiplication and we have 1 over 9. So we have 3 over 2 times 1 over 9. 3 here 1, 3 here 3. This is equal to 1 over 6. So all these numbers can get out and you have 1 over 6. The second thing you should notice is here you have cos theta and here you have cos squared theta. Now what is cos squared theta? Cos squared theta is simply just cos theta times cos theta. So 1 cos theta carry out 1 cos theta and we have 1 over cos theta. So here we have the theta over cos theta. Now this is good. We have 1 over 6 times the integral of theta over cos theta. Now the integral of 1 over cos theta is something like the integral of sec theta. So all this here can just come to sec theta into theta. In case you don't know why it's sec theta, just remember that 1 over cos theta is equal to sec theta, 1 over sin theta is equal to cosec theta. That is, I think there's an extension of trigonometric functions. Apart from the hyperbolic functions, there's also the extension. That is, I think there's SOHCAHTOA, and there's now, I don't even know the name of that one. But I think it was, hey, Kao, I think it was, the first one is SOHCAHTOA. The second one is now CHOSHAKAU, something like this. But then you have you have cosec. Cosec is equal to the hypotenuse over opposite. And you have sec is equal to the adjacent over hypotenuse. And we have sec is equal to the hypotenuse over adjacent. And we have cotangent is equal to adjacent over the opposite. So I think it's CHOSHAKAU, something like that. I don't know, maybe they put Kao through Sha, but then I shall know it's Cho, Sha, and Kao. So they are the opposite of not the opposite per se, because sine has arc sine and sine inverse. So not really the opposite, but like that, the extended family of your normal trigonometric functions. So we have the integral of sec theta d theta. Now there are multiple ways to solve for the integral of sec theta d theta. The first way to solve is instead of changing that 1 over cos theta, you can just use substitution here. The method I'm going to use is going to be manipulation. That is, this is like the straightforward way that you will get a solution for this. So here we have sec theta d theta. Sec theta, okay, let us stick with this sec theta here. If you multiply this sec theta, multiply the numerator and multiply the numerator by tan theta plus sec theta divided by tan theta plus sec theta. Then what you're going to get here is sec theta, because remember that you are multiplying the numerator and the denominator by the same thing. So if you are multiplying the numerator by x and dividing by x, you still get multiplication by 1. So you are multiplying by tan theta plus sec theta and you're dividing by tan theta plus sec theta. So just like multiplying by 1, and multiplication by 1 is just the same thing. So all these things that is here is the same thing that is down here, but there's a little bit difference. Let's look at that difference. First of all, if you say let u equal to tan theta plus sec theta, then what is du? Du would equal to, by that you differentiate tan theta, you're going to have sec squared theta. By that you differentiate sec squared theta, let's find that out, because I don't have that at the back of my head. I used to do it on paper first before I can get the value. So you have, if you differentiate sec theta, you're going to have 1 over cos theta. This is division by cos squared theta. Keep cos theta constant, differentiate 1, you have 0. Minus, keep 1 constant, differentiate cos theta, you have negative sine theta. So negative and negative, that turns to positive. So we have sine theta over cos squared theta, which is equal to tan theta sec theta. So the derivative of sec theta is equal to tan theta sec theta. So we don't really need any of this. So we have sec theta plus tan theta sec theta, all multiplied by d theta. Good. Now if you look at this here, we have sec squared theta plus tan theta sec theta. If you look at the numerator, we have sec squared theta plus tan theta sec theta. Are you seeing it? Forget that you have a plus b and b plus a, they are the same thing. So here we have sec squared theta plus tan theta sec theta. Here we have tan theta sec theta plus sec theta squared. So it's the same thing. Sec squared theta plus tan theta sec theta is the same thing as tan theta sec theta plus sec squared theta. Just that a plus b and b plus a, they are still cumulative. So what we have here, you can replace all these things here with what's up here. You can replace all this here with what's down here. Okay. So instead of, remember, okay, sorry, we have the theta here. We have the theta here. Because remember it's sec theta, the theta. So you have sec theta and that theta must be there. So all these things here is the same thing as up here. So you can replace all of this with du. And you can replace all of this with u. So we have du over u. So instead of 1 over 6 sec theta d theta, we have 1 over 6 times the integral of du over u. So you can see, just moving from one substitution to another substitution. But to avoid confusion, to avoid confusing things, I'm just going to clean this here. And I'm going to first of all solve one at a time. So the first thing I'm going to do is to find the integral of sec theta d theta, one at a time. So remember, we had the integral of 1 over u du. Now what's the integral of 1 over u du? This is the same thing as the natural log of the absolute value of u plus c. Now what's the value of u? U is equal to tan theta plus sec theta. And that's all we need basically. Now the integral of sec theta d theta is equal to the natural log of the absolute value of tan theta plus sec theta plus c. This is basically all we needed. So this is actually a standard integral. It depends on your teachers, your lecturer. Okay, this is actually a competition, so even if you just use the standard integral, I'll give you a mark. But then, let us say this is an exam. It depends on your lecturer. Your lecturer may want you to solve for this, let's prove it. Or they can just tell you, use the standard integral and go for it. Because there's no lecturer in this world that will tell you to find the integral of sin theta. You understand? It's already like a standard. So the integral of sin theta is equal to cos theta. It's actually something you can find. You can find it using the opposite around. You go for the derivative, then from derivative you now get the integral. Let me show you what I mean. Let's say they ask you to find the integral of cos theta, right? You can just say the cos theta theta. You can just say let u equal to sin theta, right? Then u is going to equal to sin. No, equal to cos theta d theta. Then find the integral of both sides. If you find the integral of both sides, you're going to have the integral of du is going to equal to the integral of cos theta d theta. Remember, this is what you're looking for. The integral of du is equal to u. And what is u is equal to sin theta. That means the integral of cos theta d theta is going to equal to sin theta. You understand? So you can just go the other way around using derivative to solve for the integral. So the lecture not actually have to solve for the integral of cos theta sin theta. But some of them actually want you to solve for the integral of sec theta. They can just show them that process and tell them that okay, the integral of sec theta is this. They can now use that integral to now get your final value. But in case your lecturer allows you to use standard integral, some of them may even give you the 6 standard integrals in your exam. So you can just go straight forward and say the integral of sec theta is equal to this, plus plug in your values and then you get your answer. But I've already shown you how to get this, so you just go and plug it in. So you have this is now going to be equal to 1 over 6 times the natural log of the absolute value of tan theta plus sec theta plus c. Don't forget your cost of integration. So these are almost our final answer. Remember, we started off with x, but here we have theta. So we need to substitute back. Now, I'm not going to tell you to substitute back as let theta equal to, I think, 2 over 3x. No, let theta equal to the tan inverse. No. Let theta equal to the sine inverse. Let theta equal to the sine inverse of 2 over 3x. Now, if you do this now, you are going to have you are going to have 1 over 6 times the natural log of the absolute value of tan sine inverse 2 over 3x plus sec sine inverse 2 over 3x plus c. You can see that is actually pretty low. So instead of going this route of substituting like this, I'm going to show you another way of substituting this. But let me first of all clean all these unnecessary parts. And just write 1 over 6 times the natural log of the absolute value of tan theta plus sec theta plus c. You don't need any of this also. But what we need now is to remember or recall that 2x is equal to 3 sin theta. Now, if you recall that 2x is equal to 3 sin theta, let's find the value of cos theta. Now, how do you find the value of cos theta? Remember that cos theta, let's square both sides first of all. Or instead of square both sides, let's divide by 3 first of all. 2x over 3 is equal to sin theta. Now, square both sides, the same process, square both sides. Now, you have 4x squared over 9 is equal to sin squared theta. So you have 4x squared over 9 is equal to sin squared theta. 1 minus sin squared theta is equal to cos squared theta. So that means 1 minus 4x squared over 9 is equal to cos squared theta. Do some algebra here. You have 9 minus 4x squared over 9 is equal to cos squared theta. Now, I think this is almost enough. Let's square both sides. If you square both sides, you have the square root of 9 minus 4x squared over 9 is equal to cos theta. I want to simplify this to the square root of 9 minus 4x squared divided by 3. Okay. So now we have 2x over 3 is equal to sin theta. And we have 9 minus, the square root of 9 minus 4x squared over 3 is equal to cos theta. I think this is basically enough for us to use to solve this question. So I'm just going to write this over here. We have 2x over 3 is equal to sin theta. And we have the square root of 9 minus 4x squared over 3 is equal to cos theta. Now let's focus on this now. We've already gotten what we're going to use to simplify this. So let's focus on this. Now how do you get sine and cos in all of this mess? This is equal to 1 over 6 times the natural log of the absolute value of tan theta is equal to tan theta is equal to sin theta over cos theta plus sec theta is equal to sec theta is equal to 1 over cos theta plus c. So this is equal to 1 over 6 times the natural log of the absolute value of sin theta plus 1 divided by cos theta plus c. You can start now by putting all of this inside that. Now let's put our values in. Okay, I'll just put it in the last row here. So you have 1 over 6 times the natural log of the absolute value of sin theta is equal to 2x plus 2x over 3. So that's 2x over 3 plus 1, all divided by this. Okay, it's actually very long to write this, so I'm not going to clean this here and write it up here. Okay, so this is equal to 1 over 6 times the natural log of the absolute value of sin theta is equal to 2x over 3 plus 1, all divided by cos theta. Cos theta is equal to the square root of 9 minus 4x squared divided by 3 plus c. This is also not needed again. So now let's focus on this. 2x over 3 plus 1 is the same thing as 2x plus 3 all divided by 3. And the square root of 9 minus 4x squared over 3 is the same thing as square root of 9 minus 4x squared all divided by 3. So here we have divided by 3 and divided by 3. They cancel out. So here we just have 2x plus 3 all divided by the square root of 9 minus 4x squared. That's basically your answer. And this is our final answer though. But as always, all these trigonometric substitutions, you can have multiple answers that all mean the same thing. So instead of 1 over 6 times the natural log of 2x plus 3 divided by the square root of 9 minus 4x squared, right? Instead of this, you can try to simplify it a little bit further. Now, this 9 minus 4x squared is the same thing as 3 minus 2x squared. So 3 minus 2 times 3 plus 2x. So you have the square root here. And this 2x plus 3 is the same thing as the square root of 2x plus 3 times 2x plus 3. So here we have 2x plus 3, we cancel out 3 plus 2x here. And what's inside this bracket, what will remain is the square root of 2x plus 3 divided by 3 minus 2x. So here instead of 3x plus 3, just put as 3 plus 2x. So it will be like symmetrical. So this is one form of the answer. This is another form of the answer. You can also still go one step further again. And instead of square root, you can clean the square root from here and multiply it from here. So instead of 1 over 6, we have 1 over 6 times 1 over 2. So here will be 1 over 12. So this is the third way to write it. And as I said, there's still more. You can still cook up some more ways to write it. You can decide that instead of division here, you are going to separate it into two logarithms. So you have 1 over 12 times natural log of 3 plus 2x minus 1 over 12 times natural log of 3 minus 2x plus c. All these are separate ways to write it. But as I said, it depends on your lecturer. Most of the time, this question can come out in your OBJ, and then you have to look at the option. So just in case you see this option, you not know about this option, you might be thinking that, oh, they're different things, but they're the same thing. So it all depends on your lecturers, how they taught you. They can teach you to leave your answer in this form. They can also teach you to leave your answer in this form. It depends on that. But as always, they'll still give you a mark. They're still meant to give you a full mark for it. But yeah, these are basically all the ways that I think you can write it. But there's still more. Now, this is the way to write it using logarithm. Now, how do you write it using trigonometry? There are some trigonometry, trigonometry, but you can cook up some plenty other ways to write it. Now, let me just give you some more. But this is the end of the solution, though. You can actually stop the video now. This is the end of the solution. I'm just giving you other ways you can write the answer. Okay. So, yeah, from this one now, we have this is going to equal to 1 over 6 times natural log of the absolute value of tan theta. And theta is now equal to what? Theta is equal to the sine inverse of 2x over 3. This is the worst way possible you can write this, because this is long as hell. And it's very not sweet because you have tan of the sine inverse. It's not really set to write. But then, yeah, it's still there. So you have tan of the sine inverse of 2x over 3 plus sec of the sine inverse of 2x over 3 absolute value close plus c. Yeah, this is another way. You also still you can really separate it to different logarithms like you are doing for this case. But yeah, this is another way to write it. So it all depends on you. And that brings us to the end of this video. I hope you learned something, and I'll see you in week 12. I know this is already October. I'm supposed to have been done with. No, this is not October. This is already like August or September. I'm not sure. I don't really check my calendar that. But then I'm supposed to have this week also since I think January or February. I've not been consistent. I know, but I'm going to try my best to finish up all the weeks till week whatever week we are in now. And I believe I'll have more than 30 other videos that I have to upload in the space of 1 week, 2 weeks. But then I'll try my best to do that. So yeah, thanks for watching. See you in the next week. And I hope you learned something. In case you want to contribute your question that you want to have, you have a calculus question you want to add to this challenge. There's 50 questions to add. I've already done, I think, 10. This is the 10th one. This week 11. So this is the 11th one. You guys want to add your own question, go to akubigobk@gmail.com. You can send your calculus question here. You can also check out other questions, that is past questions and future questions, at IgweMatics.blogspot.com. I think that is it. So it's the websites I have for all my maths things, or anything that I do on maths. I try to keep them all there. So you have IgweMatics, IgweMatics.blogspot.com. So you can go here and check for all the 1 year calculus 2026. And yeah, thanks for watching. See you in the next one. Bye bye.
Goddamn nigga. Damn nigga. Goddamn nigga. Nah, can't be a fan, yeah. Calculate. Check the variables. Running up commas, that's summation. Solve for X, that's a new placement. The logic solid.